Hi, everyone. Welcome to Boston New Technology's second DevOps Success webcast on how top CISOs or Chief Information Security Officers implement proactive and continuous security with DevSecOps. I'm Chris Requena, lead organizer for Boston New Technology, and I hope you're all doing well. BNT is a volunteer-run startup technology and business network whose mission is to help local businesses launch and grow, especially startups. We host about 3 events each month, and we gather around the community around educational and inspiring topics just like today's. This is a new series called DevOps Success, which will feature interactive interviews, seminars, and workshops with experts and leaders to help technology founders and executives manage and optimize their software delivery and support options. And we'll also educate you about the latest strategies, best practices, and technologies that will enable you to innovate faster, become more efficient, and deliver greater value to your customers. We have a couple of quick requests. If you could please share this webcast post. Social sharing is greatly appreciated. Share any comments or questions you have for the speaker on this webcast post. We'll be able to see most of your comments on Facebook. You may need to give us permission. Look for a link, and then we will feature those comments on screen for Harry to answer as we go along. And feel free to please share any learnings you have, screenshots on social media. You can tag DevOps Success on Twitter as well, and we'll retweet you. Now, with that, let me just step back here and just tell you a little about myself. So I'm a DevOps advisor at Kaiburr, where we focus on helping startups automate their software delivery, optimize their cloud services, and improve their security, which is today's topic, of course. So if you need any advice or help with your DevOps or just want to lower your IT expenses, please contact me. So without further ado, let me introduce Hariram Ananthasubramanian, CEO and co-founder of Kaiburr. Hi, Harry.
Hey, Chris. How are you?
Doing well.
Okay.
So please begin.
Okay. Hello, everyone. What we will do is we'll try to spend, on agenda items that I have listed here. We'll look at some of the cybersecurity trends in terms of the kind of threats and challenges that organizations face, and what kind of high-level challenge this generally face in terms of trying to overcome these cybersecurity threats and whatnot. Some of the core, continuous security pillars that we recommend organizations to adopt. And we'll get a little bit deeper into the core areas like security testing, security controls, how organizations have begun to use artificial intelligence and machine learning to better perform security, and some of the security agents and how they could be provisioned. And during this process, I will also give you glimpses of some of the practical examples, so you can also relate to a concept or a best practice to a real world scenario. I think that's pretty much what I'm planning to do today. So if you start with some of the cybersecurity threats and trends, showing you some of the details captured from various forums. In this particular case, this is from Security Boulevard. You can see the forecast for InfoSec in 2023 is expected to be around 151 billion. The US president's budget includes a significant cybersecurity funding. Organizations are considered 4x more effective, when they prioritize, cybersecurity incidents, when they, then they automatically get classified in the leading, category. And, you can also look at some of the other trends like the number of records that are getting compromised daily is 7 million. That's scary. There are a lot of efforts being spent by organizations to prevent security threats. Like you can see that businesses save up to 1.4 million per attack if they are doing preventive, maintenance with security. That's quite a bit. So there is a report published by IBM as well, which talks about, the average cost of a data breach is pegged at 3.92 million. And if you are, in United States, that's 8.19 million. And if you are in healthcare across the globe, the average is 6.45 million. So that's quite a bit. So it's always better that you look to shift security left and you look to enable more proactive security to avoid, these data breaches. And the another important point to note is that these breaches are not just, limited to large organizations. Even small businesses have had quite a bit of breaches. You can see a report here from Small Business Trends. 28% of data breaches in 2020 have involves small businesses. You can also see what kind of tactics are being applied by these hackers and people trying to intrude. So that should have given you some level of understanding of the importance of security, and more importantly, the importance of preventive and proactive security, right? Now, given that, let's now talk about how is security relevant in a DevOps or a DevSecOps, paradigm, right? Now, if you look at this statistic from the data breach report, you can see that 43% of breaches have happened on web applications. So they have been mostly on software that's being developed, by various organizations. So obviously, there are more moving parts when you develop software than when you're using a, off-the-shelf product. And that's why when you have active software development in your organization, it's very important to have a mature DevSecOps process. And this report highlights the importance of that. This is another, chart that highlights the fact that if you look at all the assets involved in breaches, the servers are the top, right? And, invariably it's your app server, your web server, database servers, those are the ones, in trouble. So it's important that you look at a mature DevSecOps process so you can shift security left and be proactive. Now, we know that there are breaches all around us. We know that we need to do preventive security and proactive security. We also understand DevSecOps is critical to a CISO today. Now, let's look at what challenges do they face in actually now going about solving this problem, right? Now, if you really look at it, these are the top challenges that most CISOs face today in trying to address this, right? A lot of the security policies are sitting, in spreadsheets and documents and get verified manually. The security testing itself is infrequent. You can't validate the security posture across your applications and endpoints. They're a lot of times inconsistent. If you have, 20,000 or 30,000 VMs, it's very hard to maintain that level of consistency. And it's not also performed on every release, so it gets more difficult from that viewpoint. And it's harder for a CISO to also track if it's getting performed on every release cycle. And the biggest challenge, of course, is the fact that there is no unified view for a CISO to be able to point the exact finger and saying, look, this is exactly my risk score. These are the applications at risk. and these are the critical risks to resolve, right? If you have that kind of a view, you can solve a lot of these problems, but these challenges are not simple challenges. They're hard to solve, when you have a lot of moving parts, a lot of things being in development and so forth. Now, what, we recommend, as the kind of methodology or, the process to apply in this particular case is something around what you're seeing here in terms of continuous security, right? The four key pillars of continuous security are having the right kind of security testing, things like static analysis, dynamic analysis, vulnerability scan, and whatnot. Having the right level of security controls, like having right segregation of duties, right level of access control, and so forth. Having appropriate secrets management. A lot of times not managing the secrets properly and letting them reside in scripts and files, and sometimes checking them into a repo, is the reason for the downfall. And it's also important to appropriately utilize anomaly detection and other kind of machine learning mechanisms in the process of monitoring what's happening in your environment. And last but not the least, you need to have the right level of security agents which are up to date and which are appropriate to the kind of workloads that you're running in your endpoints. So if you could have these pillars addressed at the right level of maturity and addressed together, then you would have a sophisticated continuous security followed in your organizations, which is what some of the top CISOs do today. The successful ones, the ones that are able to stay ahead of the curve by at least a few steps, are the ones that do proactive security with the kind of pillars that I'm showing here. Now, I'm just showing you a few examples of the kind of DevSecOps pipelines that you could build in your organization, so you get that level of maturity with your security and being proactive. Here I'm showing you some build and test and deploy processes, but you're seeing a lot of rules applied in terms of security, in terms of governance, in terms of engineering, as well as you see a lot of security testing steps here around image scan with Twistlock, around software composition analysis with Black Duck, code quality with Sonar. So if you could build pipelines at this level of sophistication with the right kind of rules applied to the process, you can achieve continuous security. This is a continuation of the same pipeline with more deployment and related steps. Now, we have seen the top challenges, and we have seen some of the measures that you could adopt to have a high-level strategy in place for security and continuous security. Now I'm going to drill down a little bit into some of the core topics, core pillars of security here, right? So let's start with security testing. This is one of the most important pillars, and some of the top areas to focus in terms of security testing are static analysis, dynamic analysis, image scan, OSS scan, vulnerability scan, and secrets management. We'll touch briefly on each of these topics. So when it comes to static analysis, you're mostly analyzing code sitting in a code repository, and you would ideally want to do this kind of an analysis each time you're going through the build and continuous integration process. And some of the common kind of issues found by this kind of testing can be found here. Same way, the dynamic analysis helps you to validate an actively functioning application, so that you can test for things like SQL injection, things like cross-site scripting and corruption and whatnot. Image scan is one of the most popular form of security testing these days, because a lot of new software, a lot of app modernization these days are happening in the form of containers. There is a lot of use of Docker, there is a lot of use of Kubernetes. So image scan becomes very important. This is something that you can do, at various stages of your build and release process. And once the containers are instantiated, you could also follow it up with a container scan, on a container in execution. Another important kind of testing, very popular these days, is the software composition analysis, because a lot of the software today is built with open source tools, open source libraries, and it's very important that you know that you have not used the wrong open source libraries, and it's very important you know that as early in your cycle so that you can avoid using them or you can mitigate that risk. That's why the software composition analysis tools are pretty important and popular. They help you find a lot of the challenges listed here. The vulnerability scan is, has been followed by organizations for decades. It's still extremely important, and it's critical that you do it on a as scheduled and as frequent a basis, as possible. Same way, secrets management is often, underutilized or not done to the extent required. If you really followed the good habits of keeping your secrets in vault, having the right kind of privileges for who can manage vault and so forth, you can avoid a lot of breaches this way. Every other week I hear about cases where someone left an access token in a file, someone left a password and checked it into GitHub. You hear so many such cases that have caused major data breaches and security breaches. You can avoid all of them if you had appropriate secret management in place. So, that brings us to the end of security testing. What I will do is I'll try to show you some examples here, right? So if you're performing security testing, you would want to build a dashboard like I'm showing here, right? It's showing you results of various security testing across an organization in terms of, dependency check, in terms of dynamic analysis, web server testing, network analysis, and image scan, right? So this helps you to understand which images have more issues, which applications have more vulnerabilities. So, you can then track your high-level risks and you can act on them. So, that's with respect to security testing. And if possible, you would also want to follow it up by actually validating some of the security testing results in the form of like a black duck scan here, or in the form of a twist-lock scan and so forth. But it's important you have a dashboard to track all of this, and you can follow it up with the appropriate level of scanning. So we saw black duck scan here. Let's see if we can find some image scan results here around twist-lock and so forth, right? I think this will be pretty useful. Now let's jump to the next topic on security controls. Now security controls, for the most part, do sit in Excel sheets and Word documents, because these are very hard set of items to automate. There are no standard tools out there in the market that you can just pick up and apply all the security controls you would want to apply. Invariably, all these controls around NIST, around CIS, around HIPAA, PCI, GDPR, GLBA, high trust, they all get managed in Excel sheets, and they all get validated and audited on a monthly, quarter, or a yearly basis. Very few organizations today automate that process, right? But it's possible with some of the tools out there in the market, and Kaiburr happens to be one of them as well. If you automate that, you would want to automate some example kind of scenarios that I'm going to portray here. When it comes to security controls on your CI/CD process or your DevSecOps process, you want to be able to check for, hey, do I have code quality in place? Do I have SAST and DAST testing in place? Do I apply right kind of thresholds to my testing? Do I have right segregation of duties in terms of who checks in the code, who commits the code, who releases the software, and so forth, right? Similarly, when it comes to utilization of public cloud environments, you want the right level of security in terms of IAM policies, in terms of encryption, in terms of access key rotation, and so forth. Similar best practices can also be applied on configuration files, like the example I'm showing here for MongoDB. And you could do that for Kubernetes clusters as well, which are very popular these days for modern microservices-based applications. It's important you apply controls even at that level. And last but not the least, for sure, are the OS level controls that you should apply to make sure that every possible process and every configuration sitting in your OS is as hardened as possible. So let's look at some examples of security controls now. You would want a security control dashboard like this, where you could track your overall set of controls, number of controls with issues. You want to be able to track which ones are critical and high severity. You want to be able to track how many have passed, failed, and what are the top issues, right? Similarly, you would want to also track them at a bit more atomic level, like the example I'm showing here for AWS. You should be able to drill down into a particular set of controls and validate, specific instance identifiers to know why a particular control is failing, like I'm showing here for making sure your security groups don't have 0.0 seeder, or making sure you have the right level of password policy, or that you have your volumes encrypted, and so forth. Similar kind of security controls you could apply on Kubernetes clusters. I'm showing it's important that you just don't go and use any flavor of Kubernetes out there, but also try and apply very atomic level of controls. So the clusters where you run your critical business applications are, well hardened and managed. So these are some examples of controls that we saw here. We'll now shift to the next topic, which is, security monitoring and secrets management. So when it comes to monitoring, the artificial intelligence and machine learning algorithms and frameworks available today have really matured quite a bit for you to now take advantage of them, right? You can identify spikes in resources, any abnormal behaviors in your environment. Classic examples of, hey, do I suddenly see spike in number of VMs configured or provisioned in a cloud environment? Do I see a sudden change of security group sitting in a VM? Do I suddenly see too many administrators being configured for critical software or a tool? Are you seeing a sudden increase in data out volume for a virtual machine? These are all cases that eventually lead to a breach or early indication of a breach in action. So it's important that you take advantage of the modern machine learning algorithms available out there to apply some of these practices. So I'm going to pick an example here. This is examples of some of the anomalies and abnormal behaviors in real world scenario. in this particular case, it's tracking, what's happening in a particular environment in terms of number of commits. You can see a sudden spike here. Let's see if there are other examples out here. So if you see here, this is again, a case where there is a sudden spike in the execution of a particular workflow or a pipeline process. So that can again mean an issue, right? It could be a security issue, it could be a performance issue. Here is another example, like that. So it's important you apply various models to be able to track some of these abnormal behaviors where possible, so you can, catch issues before they occur. The last topic I want to touch upon is how can you apply security agents, at various endpoints. These are some of the core category of agents you want to be considering. Antivirus, when you have Windows workloads, SSO federation, vulnerability scanning is extremely important. Web application firewall is important, and privilege access management is important as well. So you need a mechanism to be able to apply these security agents and have a view like this on, hey, what's running where? So you can actually validate your security posture, right? And hopefully when you are done with all this, you can build sophisticated pipelines like this. I'm going to touch upon some of those examples here. So here is one example of the kind of sophisticated DevSecOps process you could build, where you have the right kind of build with tools like Jenkins, right kind of handoffs and approvals with tools like Jira, Rally, Octane, the right level of code quality or static analysis with tools like Sonar, security testing with tools like OWASP, Twistlock, Black Duck, functional testing and load testing with tools like Selenium and JMeter, and the right level of approval, deployment automation with tools like, UCD or Spinnaker and so forth. Let's look at another example of pipeline. So this is another example where you have a lot of rules being executed around compliance, around DevOps and CI/CD. And you have other kinds of security testing and deployment automation being performed. So these are some examples of the kind of DevSecOps pipelines or CI/CD pipelines you would want to build. So you have a much more mature, security being applied, as early in your development cycle as possible. I think I want to take a pause here. To summarize, we looked at, high level kind of trends in the industry. We looked at some of the common security challenges faced, some of the high level best practices in terms of security strategy, in terms of continuous security. And we drilled down into security testing, security controls, applying machine learning, and being able to have the right level of security agents, and more importantly, having robust, sophisticated DevSecOps processes and pipelines, CI/CD pipelines with the right level of security thresholds in place. Let's see if there are any questions so I can, handle them accordingly.
Hey, Harry, I have one quick one, I think. So you talked about hardening. Could you just explain to people more about what that does?
Sure. So hardening by itself is a broad topic, right? So, you start generally with OS hardening. So if I go here, I'm showing you, some of the hardening that you could do on every operating system, because generally a lot of the breaches and issues start with, the operating system. So if you apply right kind of hardening on your operating systems, there are standard benchmarks available, like CIS benchmarks are a very popular one and always up to date. You can then apply those kinds of hardening rules on various operating system like Linux, Windows, and so forth. So your operating system is always robust and without flaws, right? Now, the same hardening also applies to hardening your, containers in terms of your images. That hardening happens with your image scans and so forth. You need to also harden the clusters where you have your runtime operating. So if you take a Kubernetes cluster, you need to make sure the cluster also is hardened, that the various properties set up are in a manner where there is minimal chances of a breach or a gap or a vulnerability. So you can harden those clusters as well. So those are three examples of the kind of hardening that you can do in today's modern kind of software development.
Okay, so is hardening essentially tightening the security on these various components?
Yep, I think that's a fair statement.
Okay, cool. We had a question from, it says Chai with Sai. Is your tool capable of collecting and reporting XVUL and management and security results, or do you integrate with the tools? And what are you offering as a single pane view of the reports?
Yeah, I think I think there are a few sub questions in that question. So I think the way I would answer that is with this slide, right? We help in making sure you have the right level of security testing, at every atomic level as possible with a SAST or a DAST or an image scan or a container scan and so forth. And we, enable open source tools like OWASP, Nikto, Claire, and we also enable commercial tools like Twistlog, BlackDuck, Veracode, Sonar, and so forth, right? Similarly, the security control is where a lot of the gaps are left open, and we automate the entire security control process using proprietary, data collection, canonicalization, and the rules engine. We call it a controls automation framework. You can automate, very detailed and sophisticated levels of security controls across the organization, like the ones I'm showing here, on segregation of duties, access control, and configurations and data protection and so forth, right? And once we do this, we also help in enabling hardening across various resources by applying the hardening through our workflows and deployment engines. We also help in enabling a fully orchestrated CI/CD pipeline with the right level of security and compliance, and bring machine learning methodologies to the fore, so you can now use all this data to apply right level of machine learning models to identify risk, right? Now, the cherry on top essentially is the high level organization level dashboards that we produce that help you in tracking the overall risk. What's your risk score, and be able to then drill down saying, what are my security testing risks, what are my security control risks, what are my compliance risks, and be able to drill down from there in terms of the top applications to worry about, the top environments to worry about, and go and operate on that, right? So we help you to go from a very high level view to where exactly to worry about, to a very atomic level on a particular application or a particular code base or a particular VM to go and fix a vulnerability on.
Okay, super. So Harry, I think part of Sai's question was about how we implement the dashboard at Kaiburr as far as how we integrate with those services. Can you just tell us a little more about that?
Sure. So, I think if you take this, let me go to... So if you look at this one, it's basically bringing together security testing results from different tools. For dependency check, it's bringing from tools like OWASP. For dynamic analysis, it's bringing from tools like Veracode. For vulnerability analysis, it's bringing from tools like Qualys. For network analysis, it's bringing from tools like Nmap, OpenVAS, and so forth. For image scan, it's bringing results from tools like Twislog, Aquasec, Claire, and so forth, right? So this is a classic example of the kind of varied set of tools that we enable to both operate and perform testing, but also bring them together, aggregate the results so that you know exactly the top risks to act upon. And once you act upon them, these dashboards automatically refresh themselves to tell you whether you are green or not.
Yeah, I mean, one thing I'd like to make clear is that this is real-time data, so it's being all pulled freshly, right?
Correct. If you can see this widget, it says a minute ago. So it's very close to real time, whatever data points you track and whatever testing you perform.
Super. I know a lot of people are interested in the AI aspect and machine learning and that sort of thing, and a lot of people are still kind of newbies to all of that. So could you talk a little bit more and maybe mention a couple of the specific tools or software that you've seen work well for using AI to help with security?
Absolutely. So when it comes to AI ML kind of aspects, there are many algorithms out there to detect anomalies, to predict performance issues, to predict security issues, as well as to identify root cause. Right now, we generally use quite a few models, both open source models available through Python libraries or libraries, as well as some of the models available through, the cloud providers like AWS, and Azure, and Google. And I'm just showing you an example of the kind of models we have applied, on a pipeline process, so it can flag, when things are abnormal. So there are a lot of models, and there is a lot of data aggregation happening in the background for you to get this simple chart here, right? The advantage of using these models today is that there are just too many data points out there, right? Every organization, if you are an organization with, let's say, 500 pipelines, and if you're going to run every pipeline 10 times in a day, you're talking about 5,000 executions of the pipeline per day. If you're going to multiply it for the week and for the month, it's just too much to analyze manually, right? So that's where these machine learning models help you to find out these abnormalities so that you can focus only on them. Like I'm showing you cases out of millions of such executions where I'm only highlighting some 10 or 20 of them here. So this way you can spend meaningful time on only the high value items or items of real interest, so you can get rid of a lot of the false positives, right? You can do that if you apply these machine learning models like I'm showing you in this example.
Okay, super. I don't see any more questions coming in here. Do you have any other examples that you'd like to show?
Yeah, I mean, some of the, even here, if you look at it, I've seen, in the last 3-4 months, quite a few cases where there are breaches associated with some kind of a cloud environment being over provisioned, or sudden increase in volume of data being taken out of an environment and so forth. All those kinds of things you can really validate with the machine learning approach like you're seeing here, right, where that would be one of the topics. Similarly, it's important that you also apply your best practices on your CI/CD process like I'm showing here. Similarly, if you're applying various pipelines and if you're applying various branching strategies, it's important that you apply policies like this so that you can get to the nth level of detail and be able to find out where you can improve and improve upon that, right? So I think these are some of the examples where you could then take this, apply to modern software development, modern infrastructure management, and so forth, and get more automated insights that you can act upon.
Okay, awesome. Well, I think that using AI in security is a great topic, and we'll plan on an episode of DevOps Success around that for a future time. I think we're kind of running out of time here, so I'd like to just ask everyone, if you have any particular topics that you'd like us to cover in this series, please contact me. You can contact Harry as well, of course, and we'll do our best to work on those. And we will be inviting more guest speakers as well. So if you are an expert in an area of DevOps, you can also contact us to participate. And Harry, what final words can you offer before we wrap up here?
Well, I hope the session was useful to you, and I hope it, made you think more about some of these topics and make you get better at proactive continuous security. And nothing else. Have a wonderful rest of the day or evening wherever you are.
Awesome. Well, thanks a lot, Harry. Thanks again. And again, if you have any need around DevOps, need any advice or help, or just want to reduce your total IT expenses, feel free to contact us. Our next DevOps Success webcast will focus on quality assurance related topics. So look for that to be announced in our newsletter in the next week or so. And Boston New Technology has our next startup showcase on clean tech, green tech, and energy to take place on September 16th. And again, look for our newsletter for that announcement. And since we can't hear claps in this virtual session, please wrap up with a like or comment or any positive feedback you have. We'd appreciate that. And again, I thank everyone for coming, and we hope to see you at a future webcast. Cheers.
Thank you.